So in this video, we'll continue our discussion on finding the volume formula for the solid. And in this case, I'm talking about the solid based on this shaded region. And you're trying to rotate this region by 360 degrees along the x-axis. And you can try to imagine what kind of solid that you're getting here. So if you use the x-axis as the axis of rotation, roughly speaking, you're getting a picture like this. And I understand that my drawing is not perfect, but I wish that you can understand what I'm talking about. And by the shell method, what you need to do is you can take a horizontal red line. Please remind yourself that such a line needs to be taken which is parallel to the x-axis, you see. So you need to take a line parallel to the axis of rotation. And in that case, if you take such a line and rotate this line along the x-axis, you are basically getting a shell like this. You're basically getting a shell like this. And if you recall the concept from the last video, and informally speaking, now the volume of our purple solid, you can think of it as a purple solid you're given like this here, and you are trying to peel off layer by layer of this solid, starting from the outermost layer and to the innermost layer, and each layer is just infinitely thin. So one layer is really just like a paper, right? It's two-dimensional paper. And informally speaking, to find the volume of the purple solid, you can think of it as summing up the surface area of the shell, which is formed from the innermost shell based on this lowest point. You see, this is the innermost shell, and gradually, shell by shell, you can go to the outermost shell, which is formed by the outer line, which is the upper line here on the two-dimensional picture. So basically, I'm saying that is the sum of the surface area of shells from the innermost shell, which is based on the point y equals a, up to the outermost shell, which is based on the point y equals b, right? And same thing as before. Let's look at the meaning of the surface area of a shell. You see, one shell is like this. And please let me know the surface area of the shell. If you unroll it, you get a rectangular paper, and you see the surface area of this shell is the same as the area of this rectangle, right? And this rectangle, you can put it per parameter like this here, and the area is basically BH. And let's look at the meaning of each length here. The H is what? The H, which is the horizontal length of this paper, is the same as this length basically. And this length is what? This length is basically based on this line, right? Please take a look at this shell. And this line, let's come back to the two-dimensional picture. It's basically this length. This length is basically the x-coordinates of this point. If you're given a function y equals f of x, the x-coordinates, mathematically, you can present it by x equals something g of y, right? Basically, you have to do a transform from the equation y equals f of x to something x equals g of y. And that represents the length of h here. So h is basically g of y. So how about b? B is the vertical length here. You can basically roll it back. So basically, I used another color to make it more clear. If you roll back this black line, you get a circle. And of course, the length of the circle is the same as 2 pi r, right? That's the length. And what is r here? The r is basically this length. The r is basically this length. And let's come back to this picture. The r is basically this length, right? And let's come back to this picture. The r is basically here, right? So this length r is exactly the height of this point, and this point is based on what you choose from A to B, right? If you choose the lowest point, which is y equals a, the height is just a, right? If you choose the uppermost point, the height is b. And in general, if you choose a point y naught, the r is gonna be y naught, right? And I think it essentially means that the b is based on 2 pi r, which is 2 pi y, basically. Y is the position you choose between a and b. And from here, we can write the volume formula down. The formula is gonna be a y integration now because you're going along a and b, you see. And the content inside the integral represent the surface area of shell. And one surface area, we understand that is the same as 2 pi y g of y. So I put it here, 2 pi times y times g of y here. And this volume formula will help you find the volume of this purple solid. And let's look at an example now. So please look at the current picture. I would like you to tell me the volume formula of the solid based on the black shaded region, and also please do the x-axis rotation. And now please recall what we did in the previous part by the cylindrical shell method. You have to take a line which is parallel to the axis of rotation, and now the axis of rotation is x. And based on my previous formula, it's going to be 2 pi y g of y and dy AB, right? And let me tell you that this line is actually y equals x squared. And please tell me the correct volume formula now. And now, you see, you have to do the dy integration from 1 to 4. So I put it here, and the content inside the integral is 2 pi y times g of y. So what is g of y? G of y, you should basically represent this length, which is the x coordinate of this point. And the x coordinate, of course, is based on this function, which is x equals square root of y, right? So I just put it like this here. And that's basically the volume formula of this picture. And I trust that you're able to do this computation, but I write the steps for you. So basically, I've just written down all the computations for this integral, and this answer you can easily get it numerically by calculator, and that's exactly the volume of the solid, which is based on the picture we put up here, right? So that's the end of this video.